Okay, so still on algebraic expression, lesson 4. We are going to study how to multiply two binomials. If we still have ample time, I will start doing factorization with you. Let's start. Multiplication of two binomials. All right. Okay. What is a binomial? A binomial is any expression having two terms. Okay. For example, a plus 2. Okay. It's a binomial. 4 minus say 9z. All right. It's a binomial. Okay. Because with these expressions, they all bear two terms each. All right. A term, a term. Last time in our first lecture video, I told you that you can count terms when they are separated with a plus or a minus. You understand that? So apart from that, you can also base on the multiplication sign or perhaps the division sign to count values as terms. All right. It's only addition and subtraction. So over here there are two terms. All right, two terms, and any expression with two terms we call that binomial. So basically, under this study, we are going to learn how to multiply two binomials. Okay. Now, doing this, we are going to apply the distributive property. I think I used that in our previous lecture, and we are doing this again. Okay. So you in the distributive property, you're going to pick each term here, and then use it to multiply every content in the next bracket. So a will multiply everything here, and then 2, positive 2, which is left, will also multiply everything here. All right. In that case, we would say the multiplication has been done effectively. Okay. All right. So that is what we are going to do. But before we get in, I would like to introduce you into some basic algebra in multiplication that will really help you conduct these multiplications with ease. All right. So take a look at the following rules. Rules. Okay, so a times b, I mean multiplying two different variables. All right, what is the answer? It's going to be ab. So if you see anywhere, don't be surprised. I hear the next one, a number multiplying itself. All right, well, without wasting my time, this we can apply the laws of what? Indices. So since the base are the same, you pick one, and then because they are multiplying, you add the powers. All right, so it's going to be 1 plus 1, which is what? 2. I told you all have a power of 1, which we normally do not write. Okay, the next one, 3a times 2b. So we've been doing a lot of these. What do you think will be the answer? So 3, the numbers will multiply themselves. Okay, 3 times 2 is what? 6. Then the variables, of course, they are not matching, so you just write them, drop them. Okay, I also have 5b minus 2b. So this is referring you into the what we did in addition and subtraction of algebraic expressions. So you know there are like terms. Okay, they are like terms, so you just subtract the numbers, which will give us 3. Then because they are all common, you pick one. Okay. All right. How about this one? These are some major rules I would like you to know before we can start these. So 3a squared plus a squared. You see, because of the a squared, we would say these two numbers are like, these two terms are like terms. Okay, yes. Regardless of the number in front, like terms, they are terms having the same variables and powers on variables either. So Well, because they are like them, we can just add the numbers, and there is 1 in front. So 3 plus 1 is 4. Then you just drop the common term they all have. Mind you, it's only with multiplication and division you apply the laws or rules of what? Indices. The next one. Minus 2 multiplying x plus 3. So over here is equally the same as what? Removing brackets, okay? So minus 2 multiply x and you get what? Minus 2x. And then minus 2 will multiply what? Positive 3. And I just said that in our previous lecture, negative is dominant over positive, and so you're going to have minus what? 6. 2 times 3 is what? 6. Okay. This is the first rule. Second, 3, 4, 5, 6. Okay, let's try more. Three times a, what would that be? So of course, this is going to be what? 3a. Right there. We've done so much of it. There's a variable in front of the a. That's 1. 3 will multiply it. And of course, it's going to give us 3. There is no matching variable, so that is it. Then number 8. (3a plus 2a). You can just take the idea from the fourth one. So the variables attached to the coefficient are the same, so they are like terms. So 3 plus 2 will give us what? 5. Then you drop the common variable. Let's do more, so we can easily carry on whatever we have doing today. So 3 times a squared. Can you pause and answer this? Of course, there is a variable in front, 1. 3 times 1 is what? Is it not 3? A squared doesn't have a matching variable, so you just drop it. Okay. Let's move on. So if you meet it anywhere, you should apply the same concept. 2a plus ab. Sorry, 2ab plus ab. So what is it? So over here you see the variables are the same, okay? So you just add the coefficient. And the coefficient is what? 2 and then 1. So giving us what? 3 what? So we're going to have 3ab. You just drop the common variable they are all sharing. Number 11, of course, that's the last but one. How about this one? This removing bracket. So what did I say? 2 will multiply each single term inside the bracket. So that's going to be 2a, 2 multiplying a, plus what? 2 times 3, which is what? 6. And lastly, the last rule I would like us to talk about. I'm doing this because of the application of integers. We have done this already in our previous video. Go watch that. Alright. So you see, negative 2 times 3 times x is going to be what? Minus 2x. Okay, let me write the answers below. This is going to give you minus 2x. Then you have minus 2 multiplying minus 3. Minus meet minus, it tends to be what? Positive, alright? So plus, then numbers multiplying, that's what? 6. So it's minus 2x plus 6. When negative multiplies negative, the answer is positive. We have done this already. Alright? So that is it. Let's move on. Alright, so with this idea, I would like to solve this question since I generated myself. And when we are done now, we can start simplifying some questions, okay? Okay, so it's here. So we are asked to multiply these two binomials. Let me write it up there. A plus what? 2. So you can see this is way different from what we did in our previous lecture. That one, it was just a bracket and then there was a value outside. So multiplying is, what are you going to do? So I said we are going to use the distributive law, not forgetting these rules when you meet them. The distributive law, this is how you're going to do it. You pick each term here and use multiply everything here. Let's start with A. So you pick A, then you use that to multiply everything in the other bracket. That's 4 minus what? 9z. And then what is left? Plus 2. What is left? Plus 2. Okay? Use that to multiply that's to 9z. Now, A times 4 is going to be 4A, then minus A times 9z will be what? 9az. We just did that. So A times 4, that's 4A minus. You see, this can be related to, where is that? Can be related to, hold on. All right. So, well, more or less like this, yes. So, removing bracket. Well, let me take the opportunity to explain to you. So, over here, A will multiply for, we've done this already. That's 4A. And then A multiplying minus 9z. This is positive, all right? There is a number in front, which is 1, positive. So 1 times minus 9 is minus 9. Okay, then A times Z, of course, easy. So that's what you see there. So plus, so here 2 times 4 is what? 8 minus 9 times 2 times 9z is what? 18z. That is it. So afterwards, you now group the like terms and simplify. But of course, none of the terms are like one. So this is your final answer. This should be your final answer. Unless perhaps you see like terms there, but there isn't. Okay. So this was just by the way. Now this is what I structured for you. Let's try these. Simplify I. You have A plus 2. Then another one is what? A plus 3. I. You have 2x plus 3 squared. I. Multiply x minus 2, okay, by x plus 3. All right, let's do these first. So solution. So with the first one, I said pick the first each term in the first bracket. You use it to multiply everything in the next bracket, okay? So this is what you should have. A into bracket. So this A will multiply all these. What are you left with? You'll be left with what? Plus 2 there. Left to be multiplied to the other side of it. Alright. What you are done? What are you getting? A times A is what? A squared plus A times 3 is what? 3A plus 2 times A is what? 2A plus 2 times 3 is what? 6. Good. A times A squared 3A. Alright, just relate it to what we've done so far. And then you group like terms. It's obvious. The terms are already grouped. Okay. So see, A and A, they are like terms, and so you just add the numbers, giving us what? 5. So you just drop the similar variable they all share, and then plus what? 6. That's it. This is the final answer. Because none of the terms now are like the ones. Okay. Let's move to the next part of it. So you have 2x plus 3 all squared. Alright. When you mean this means 2x twice of 2x plus 3. I mean, so it's 2x plus 3 multiplying another 2x plus 3. So when you mean this, you can just write 2x plus 3, then you square that. Either or me. We call that perfect squares. Okay. Likewise, when you mean this, you can re-express as this. So what if it's cube? What if it's cube? I mean, it means 2x plus 3, another 2x plus 3, and another 2x plus 3. Alright. Thrice of that. Now, applying the same distributive rule, you're going to have 2x, this one, alright, will be used to multiply everything in the other bracket. Then, plus 3 is left. It will be used to multiply everything in the other bracket. So, in the long run, you have in, now watch closely, 2x times 2x. That's what? 4 x times x, alright? They are the same, of the same base, and they are multiplying. So you add the powers. That's going to be x squared. X is to a power of 1, okay? So that's the reason why I squared that. Because I added. Then plus, now you have 2x plus, multiplying what? Positive 3. Of course, a number will multiply numbers, alright, which will give us 6. Then you drop the variable, so plus what? 6x. And then plus 3 times 2 is what? 6. You drop the x. 3 times 2x, 6x. Then plus what? 3 times 3, which is what? 9. 6x and 6x, because of the x, we say they are like terms. They are like terms not because they are, I mean, it's 6, 6, no, but because it's x and here is also x. So we would have 4x squared, alright, plus 6 plus 6 is what? 12. So you drop the common variable, then plus what? 9. This is my final answer. Okay. So I believe you can do the I. Do it yourself, and then you can play the video to check my solution. Whilst I solve it here. Okay, so we have x, I, by the way. So we have x plus x minus 2, okay? Multiplying x plus 3. Actually, this is how you should be presented. This is how you should be presented. Okay? So let's solve that. So you have x multiplying what? X plus 2. X plus 3, sorry. Then you are left with what? What are you left with? It's I'm much particular about this. Minus 2 is what is left. This is multiply everything in the other bracket. Okay. Okay, so what are we getting? X squared plus 3x. X times x, x squared plus 3 times x, 3x minus 2 times x, 2x, alright? Then minus will meet the plus because multiplying become more. So watch. Minus 2x, minus 2 times positive 3. And I said minus is always dominant. And so you get minus what? Then 2 times 3 is what? 6. And then you group like terms before you solve. Over here, the like terms are actually matching each other at one place. So you just solve. 3x minus 2x. Of course, it's going to be plus 1x or x, alright? 3 minus 2 is 1. 1x. I've said it over and over again in our previous video. Alright, so that is it. Okay. Please try the following yourself. Try the following. So, Ivan. Multiply 3x minus 2y, all right, by 3x plus 2y. V expand 3x minus 2, 3y plus 4. All right. Let me add one more, so we'll be left with 2 from my examples. Okay. Multiply 2x plus y by 2x minus y. Okay. Shall we? Okay, so with the first one, before that, let's write the answers in front. You know the importance soon, and I would like to rub the solution, so let's write them beside them. Okay. Over here too, I think we had what? 4x squared plus 12x plus 9. And with this one too, we had x squared plus x minus 6. All right. So here's solution. Of course, you're going to have 3x multiplying 3x plus 2y. All right. And then, well, let's rewrite the question. All right, for a clear view. So 3x minus 2y in one bracket, 3x plus 2y. This is what it means to multiply this by that. So you pick 3x first. You multiply everything here. All right, plus 2y. Then what is left? Minus 2y. Okay. You multiply everything here. Again, you pick 3x. Then you multiply everything in the other bracket. What is left? Minus 2y. Use it to multiply every content in the other bracket. So in the long run, 3x times 3x, I mean this times that, will give you 9x squared. The square is coming from the application of the laws of indices here. X similar base, the power is 1, so you add them. So you having 9x squared, all right, plus 3x times 2y. You're going to get what? 3 times 2 is what? Is it not 6? Well, they don't have matching variables, so you just drop them. Okay? And then here, 2y times 3x minus already repeated, so that's going to be 6xy, all right? And then minus 2y times 2y, which is actually positive. That minus is always dominant, so that's going to be 4y squared. Now, I know you are all okay with these. The like terms are already grouped, so you're going to have 9x squared plus, 6xy, xy, you see they are like terms. Now, plus 6xy minus, that's 0. So you have in this in return. 9x squared y, x squared minus 4y squared as an answer. Maybe I should just write it beside it. 9x squared minus 4. Don't get confused. Know that what I'm writing here are the answers we discovered after solving. I don't mean it's not part of the question. These are the answers we had after solving. That's okay. Okay, so let's check the V. Maybe you should pause your video and then do this before you check my solution. The V. Alright, so let me rub this side off. We are come to solve the V. The V. So V solution. V. So expand, you have 3x minus what? 2, right? With 3y plus 4. Good. So with this one, what is the answer? First, you pick a content here, a term, use multiply everything here. What are you left with? Minus 2. So that will be used to multiply all that. So we are getting 3x times 3y, that's 9xy plus 12x. I mean, the result when you multiply 3x to 4. Good. Now minus 2 times 3y is going to be minus 6y. And then minus 2 times positive 4 will definitely be minus what? 8. Remember I told you negative is always dominant. Are there like terms? There are no like terms. So this cannot be solved further. And that can be now regarded as our final answer. So the result for this one was 9xy plus 12x minus 6y minus 8. Let me say this. Please zoom, all right? First, your phone should be on landscape. All right, when playing the video, your phone should be on landscape, okay? And then also try zooming in order to see the writings very clear, all right? Forgive me, but this is how best I think I can put it, all right? Okay, let's come to the VI, sorry. So we're doing it here. VI. So with the VI, of course, that's the last one. This was V. You have 2x plus y. We are being asked to multiply it to what? 2x minus y. Okay, so what are we getting? 2x, that's the content here. We'll be used to multiply all that here. What is left? Plus y will also be used to multiply all that there. And it's obvious, 2x times 2x, now you should know 2 times 2 will give you 4, x times x will give you x squared. 2x times minus y will be minus 2xy plus 2xy minus y squared. You can take your time to take a look. 2x y times 2x will give you what? 2xy, then minus positive y, multiply minus y. Of course, it's going to be minus. Remember, I said there is a number in front. So that's going to be minus 1. Y, the power is 1, so that's going to be y squared. I said that 1 being a coefficient, we usually do not prefer writing. You should have 4x squared minus 2xy plus 2xy will give you 0. Mind you, they are like terms. So you'll be left with 4x squared minus y squared. Alright, please, if it was really quick, you can play the video back again to get a concept, okay? Alright. Okay, so far so good. We've been able to produce results for the questions that was given. Okay, let me wrap these. Okay. Wow. This was also a solution. Let me wrap it for space. All right. Maybe you are writing this. Okay, student, take a look at this. So this is the ideal way to multiply two binomials, okay? Let me show you a quicker way to solve some questions and a multiplication of two binomials. Actually, it's not for all, but when questions appear in some specific ways, there are usually a quick way to solve them. Either, well, you shouldn't do this in examination. Okay, I mean, for general questions like this, what I'm come to do, don't do it. Okay, when they come as a main question, don't do that. You lose marks. Okay, what I'm come to do, you should do them when you have a main question where these are just steps. Okay, part of the steps. All right, you can do what I'm come to do to reduce steps to arrive at the solution very quickly, and then you move on. All right, good. And then also for multiple choice questions where you just have to select when your workings is not really needed, going through this way might be long. All right, for the ones I'm just come to handle that with you, so you just apply the short way. All right, so we'll start with questions like these. Okay, so the answer is there. We have 2x plus 3 all squared. We're asked to simplify, and I told you with this one, it means 2x plus 3 multiply another 2x plus 3. Then you apply the distributive property. We have already done that. Let's look at a different way. Alternatively, this is for multiple choice questions, and then when it's just part of a solution. All right, it's not a main question. Okay, so we basically call these perfect squares. Perfect squares. Okay, so it's only with a binomial squared. Again, it's only with a binomial squared. So can you see anything which is similar to this in the questions we've solved so far? No, there isn't. All right, but let me produce one. So something like this: 29. No, let me use small values. 5mn plus 14. All right. 14 what? I want to use small values, so plus or let's say minus 2a, all right, all squared. So this one, it is also a perfect square. You see, I just changed the symbol. It's a perfect what? Square. One is a binomial square, all right. This, you apply the same concept anyways. So this is a perfect square. Now, how do we solve them? Pay attention. So this and so much more is a perfect square. All right. Now, the shorter way is that first pick the first term and square it. All right. So this should be something in your jotter. You have 2x. All right. So pick the first term and square that. In algebraic expression, when you have a content in brackets squared, the square affects each single term inside. All right. So over here, 2x squared means the square will affect the 2, making what? 2 squared, which is what? 4, isn't it? The square will affect the x, making x squared. So first, by writing the answers a shorter way, square the first term. All right. So that's going to be 4x squared after doing that. Then the next one is that, what are the terms inside the bracket? Just multiply them. And the answer you would get, use the power to come and multiply the answer. So again, what are the contents in the bracket? So you have 2x and then what? 3. Multiply them. You should get 6x. 6x. Now, the answer you would get, use the power to multiply. Listen, the terms in the bracket is 2x and positive 3. But I told you when a plus is in front of something, we don't write. Okay, so 2x and positive 3, making 6x. And then use 2 to multiply the answer, making what? 12x. So you write it as part of the answer, 12x. It's actually positive. And the last thing is that, you see, you square the first term, square the last term too. Okay, so the last term there is what? Positive 3 or 3. So when you square it, 3 squared is going to give you what? Positive 9. So this, you see, is very short. This is the final answer. Let's see if that's what we had. So you see, 4x squared plus 12x plus 9. We had the same thing. Good. Let's form one more. Let me form one more and do that with you. So when you meet it anywhere, you would be able to. But you can write your own notes, by the way. So for instance, assuming I give you 5mn, all right, minus 2 all squared. Pay attention. So the shorter way is what? The shorter way is you square the first term, all right. The first term here is what? 5mn. So you do what? You square that. Squaring this, what is the value? I said the square will affect each content inside the bracket. So 5 squared will be what? 25. And then it will affect the m, making m squared. It will affect the n, making n squared. That's the proper way to do this in algebra. So you square the first term, and then the next thing is that you multiply the contents inside the bracket. The terms inside the bracket is 5mn and then what? Minus 2. Multiply them. So you're going to get, you know this already, that's going to be minus 10. 5 to what? 10. Minus 10 mn. So I said the second step is what? Multiply the terms inside the bracket and then what? Use the power to multiply them, the final answer. Use the power to multiply, and of course in all the cases the power will be 2 because that's the only question you can apply the shortcut. So use 2 to multiply the answer. You're going to get what? Minus 20 mn. Okay, and the last term is what? Since you square the first term, square the last term. The last term is minus 2. So if you square it, now this is going to give you 4. All right, so plus what? 4. Okay, let me say this. When you have a negative component in a bracket raised to an even index or an even power, all right, even index. The even numbers are 2, 4, 6, and so on. When you have a negative content in a bracket raised to an even index, okay, the answer must be positive. With the scientific calculators you are using in senior high school, if you put this on the calculator just like this, okay, just like this without a bracket, it will give you negative 4, but it's incorrect. Okay, so to achieve the right answer, just as I'm telling you, what are you going to do? Put it in bracket. When you square it, you discover that it's going to give you 4. Again, when you have a negative content inside the bracket raised to an even index, the answer should be positive. So you check how you use your calculators. So that is it with perfect squares. Play the video back again and you will be able to produce these with ease. You should know this off head, all right? Okay. The last thing I would like to teach you when it comes to the short approach, all right, is something I call difference of two squares. Under the study of multiplication of two binomials, you'll be faced with questions like that. Okay, what did I say? Difference of two squares. Difference of two squares. Okay, so a typical difference means what? Subtraction. I don't know if I said that to you initially. So a typical example is where is that? Please follow me here. Ivan, you see 3x minus 2y. Either me. Then you have in the other bracket 3x plus 2y. Questions like these, they are difference of two squares when the terms are the same, but they only differ with the sign in between. One is minus, the other is plus. Please, if it's both plus, it's not difference of two squares. If it is both minus, it's not difference of two squares. All right, good. Where else? So you see, check VI, 2x plus y, the same 2x, but what differs is 1 minus. It's a difference of two squares. All right. We are going to do more of that under factorization. See, this is not difference of two squares. Why? Well, it's minus plus, but you see, the terms are not the same. This is 3x, 2, this is 3x, no, this is 3y, and something different. Idle me. So don't take that as the difference of two squares. Okay. There's also not difference of two squares. X minus 2. X, well, it's plus, but this is not 2, it's 3. So what did I say? The difference of two squares? IV is 1. I there. And then VI is 1. Where the X there is X. Okay. Let me teach you the concept of difference of two squares, though I'm going to do that under factorization. It states that when you have a term square, pay attention, a term. When you have a term squared, when I say a term is a combination of a number with a variable, isn't it? It could be just a number. It can also be numbers matched with variables. When you have a term squared, okay, minus another term squared. A term squared minus another term squared. Alright. Its expansion has been proven to be this. Just pick the first term, put plus in between, and then you drop the second term in one bracket. Then you start again with another bracket. The same first term, this time around, put minus in between, alright? And then you drop the second term. So a term squared minus another term squared. Pick the first term, put plus in between, you drop the second term, alright? Then you do the same thing, but you change the sign. So meaning if you meet this, you can use this. If you meet this, you can use this. That is it in math. That's the meaning of equal sign. So take a look at this. This question, 3x minus 2y. Maybe I should put it here. 3x minus 2y, alright? Multiplying 3x plus 2y. So you see, rather than going through the long procedure, I mean, you pick 3x, you multiply these things and add. You see, a term minus another term. That same term here, there is a plus. Don't they look alike? A term plus, you see, that same term, but the sign changed. Either with me. They look alike. Either. Maybe I should just make here minus and then make here plus for you so you can see it very well. But I mean, it's the same. Either with me. You see, they look alike. So what do you do? So meaning, initially, it was a term squared minus another term squared. Because that is difference of two. Difference means subtraction. Difference of two terms squared, alright? It's only difference of two squares that give rise to expressions like this. So just consider the terms involved, which is what? 3x and who? Minus 2y, please. Either of me. These are the terms involved. Can I move on? So what are you going to do? You are going to, what are the terms involved? It's 3x and 2y. I'm sorry. 3x and 2y, either. So you just square them. That's all. So squaring this, I just told you. You're going to get what? 9, 3 squared making 9. 9 what? X squared. So a term squared minus, square them and subtract. So minus what? 4. That's the result from 2 squared. 4 what? Y squared. Do you understand that? Once you see them as difference of two squares, result from difference of two squares, just take all the terms. 3x and what? 2y. And then what do? You square each of them. Then you take subtraction. So that is it. If you expand this using the long way, you're going to arrive at this. I think that's what we had. Go and check that. Ivan, 9x squared minus 4y squared. Let's do more. So take a look at this one. So they were asked to multiply 2x plus y to 2x minus y. And immediately I thought 2x added to y, 2x minus y. This a difference of two squares, alright? Results from a difference of what? Two squares. The difference of two squares, okay? So just pick the terms involved. That's 2x and y. Square each of them and then put minus in between. Because when you have something like this, what are you going to do? You see difference of two squares. You pick 2x, you put plus in between, you drop the y. You pick 2x again, put minus, you drop the y. So it's the same. And I mean, 2x all squared is what? 4 results from 2 squared and then x squared minus y squared. So if you go the longer way to simplify this, you arrive at this, and I guess that's what we had, vi. That's fine. So student, this is because we're doing algebra. I want you to know this. So in the subsequent topics I'm going to treat with you, where we'll be having lengthier solutions, we do not have to go through the order of breaking this down. You pick this one, you multiply this and all that, wasting our sheet. All right. When we get there, we can easily quote these values and then progress to what is left for us to do. Okay, let me give you some example. I will not try. Please do it. In our next lecture, I will do it before I will start with factorization. Either way. Take a look at this one. So I want to clean the board. So the shorter way, we studied perfect squares, and then we also learned difference of 2 squares. Please keep that in mind. So this is your task. VII. I want you to multiply multiply 4x plus 3y by 4x minus 3y. Then VII. All right. I want you to simplify 2a plus b in one bracket, a minus b in the other bracket, plus 2a minus b. Okay, student, with the example solved thus far, together with just these two I've given you, you can see that even with this one, it's a difference of what? 2 squares. You should know the answer already. Alright, you should have 16x squared minus what? 9y squared. When you go solve that, you should get the same thing. Alright, and then the last one, with the examples solved so far, so this and the last one, with any question you would meet under multiplication of 2 binomials, I strongly believe that you can do that yourself. If you find this lecture video so helpful, try and share so it will reach your colleagues too, alright, so they can also have benefit of that. If you have not subscribed to my channel yet, kindly do so. Alright, in our next lecture, I'm going to do factorization and some few other relevant things you need to know under algebraic expression before we can end the topic in the whole. Alright.